The James Webb Space Telescope just sent back images that made the world's top physicists question everything. And I'm not exaggerating. In January 2026, NASA released data that reveals galaxies that shouldn't exist, black holes that break the laws of physics, and a universe that's 10 times larger than we ever imagined. But here's what's truly terrifying. What Webb found suggests that everything you learned about the Big Bang, about how the universe began, about the very fabric of reality itself, I might be completely wrong. We will about to discover truths so mind-bending that some scientists are calling for a complete rewrite of cosmology. By the end of this video, you'll understand why the scale of the universe isn't just big, it's impossibly big. Before we get into the terrifying discoveries, you need to understand just how revolutionary this telescope is. Because without Webb, we'd still be living in cosmic darkness. The James Webb Space Telescope launched on Christmas Day 2021. It cost $10 billion, took 30 years to build, and it's not just better than Hubble, it's operating in a completely different league. While Hubble observes visible light and ultraviolet, Webb sees in infrared. And that's the game changer. Infrared light can penetrate cosmic dust clouds that completely block visible light. It can detect the faintest heat signatures from the most distant objects in the universe. Think of it like this. Hubble was trying to see through a brick wall. Webb just walked around it. And what it found on the other side? Well, we'll get to that in a moment. But first, let me tell you about the scale we're dealing with here. Webb orbits the Sun at a point called L2, Lagrange point 2, about 1 million miles from Earth. Its primary mirror is 6.5 meters in diameter, compared to Hubble's 2.4 meters. That gives it approximately 6 times more light-gathering power. But here's where it gets insane. Webb can detect the heat signature of a bumblebee on the moon, from Earth. With that kind of sensitivity, Webb can look back in time over 13.5 billion years, to just 200 million years after the Big Bang. We're literally seeing the universe in its infant state. Or at least that's what we thought we'd be seeing. Because in January 2026, Webb released its latest dataset, and scientists immediately knew something was wrong. Let me take you back to July 2022. Webb's first images are released to the world. Scientists are ecstatic. They're expecting to see small, primitive galaxies, cosmic babies, just starting to form. Instead, they see this: massive, fully formed spiral galaxies, gleaming like jewels, structured like they've been around for billions of years. But remember, we're looking at these galaxies as they appeared just 400 to 600 million years after the Big Bang. According to our current understanding of cosmology, that's not enough time. Galaxies need billions of years to grow this large, to develop such complex structures. It's like expecting to see a fully grown oak tree 20 minutes after planting the seed. Astrophysicist Dr. Joe Leja from Penn State said, and I quote, "These galaxies would be so massive that they're in tension with 99% of models for cosmology." Translation: if these galaxies are real, then our models of how the universe evolved are fundamentally broken. Now, some scientists initially thought these might be measurement errors. Wishful thinking, because in September 2025, Webb confirmed it again, and then again in January 2026. These galaxies are real. They exist and they shouldn't. But it gets even stranger. Webb discovered what astronomers are calling little red dots, compact, ultra-bright objects that appeared just 400 million years after the Big Bang. At first, scientists thought these were just distant galaxies, but the more they studied them, the more bizarre they became. These things are incredibly bright, far brighter than they should be given their size. And then they realized what they were looking at: black holes, supermassive black holes, each one containing millions, sometimes billions of solar masses. Here's the problem: supermassive black holes need time to grow. They start small, consume matter, merge with other black holes, and slowly, over billions of years, reach massive sizes. But these black holes in the early universe, they're already massive. They're the size they should be after 10 billion years of growth, but they've only had 400 million years. It's like finding a 30-year-old human who was only born last month. In January 2026, a team led by physicist Dr. Enrique Gastañaga published findings that sent shockwaves through the scientific community. They suggested that these discoveries might require us to rethink the Big Bang itself, not modify it, not tweak it, rethink it entirely. Because if galaxies and black holes can form this quickly, then either A, we don't understand gravity, B, we don't understand time, or C, the universe didn't begin the way we think it did. Remember when I said scientists are calling for a complete rewrite of cosmology? This is why. So if our current models can't explain these massive early galaxies and black holes, then what can? Enter dark stars. And no, I'm not talking about the movie. I'm talking about a theoretical type of star that could completely rewrite our understanding of the early universe. In January 2026, researchers published a study in the journal Universe, suggesting that what Webb might be seeing are unordinary stars and galaxies at all. They could be dark stars, hypothetical objects powered not by nuclear fusion, but by dark matter. Now stay with me here because this is where things get truly mind-bending. Dark matter makes up about 85% of all matter in the universe. We can't see it. We can't detect it directly. But we know it exists because of its gravitational effects on the visible matter. Current theory says dark matter particles occasionally collide and annihilate each other, releasing enormous amounts of energy. In the early universe, when dark matter was more concentrated, these collisions would have happened frequently. And here's the crazy part, that energy could have powered stars. Dark stars would be absolutely massive, millions of times larger than our sun. They'd burn incredibly bright, and most importantly, they could have formed much earlier than normal stars. This would explain the blue monsters, ultra-bright galaxies Webb detected in the early universe. It would explain the little red dots, and it would explain how supermassive black holes got so big so fast. Because when a dark star dies, it wouldn't just collapse into a regular black hole. It would collapse into a supermassive black hole, already billions of solar masses in size. One event, one collapse. Instant supermassive black hole. No waiting billions of years. No slow accumulation of matter. Just instant cosmic behemoths. But here's what keeps cosmologists awake at night. If dark stars are real, then the early universe was a completely different place than we imagined. And that raises an even bigger question, one that Webb is now forcing us to confront. What if dark matter isn't just stuff that exists in the universe? What if it's the foundation of everything? What if visible matter, stars, planets, you, me, is just the exception to the rule? We'll come back to that. But first, I need to show you something even more unsettling. Because while scientists were wrestling with impossible galaxies and dark stars, Webb revealed something about the structure of the universe that changes everything. On January 26, 2026, NASA and the University of California, Riverside released new data from the James Webb Space Telescope. They'd been using Webb to map dark matter in a region of space previously observed by Hubble. And what they found completely rewrote our understanding of cosmic scale. This image is from the Cosmos Web Survey, the largest and most detailed map of dark matter ever created. It covers an area of sky about twice the size of the full moon. Doesn't sound that impressive, right? A tiny patch of sky contains over 800,000 galaxies. 800,000 galaxies. In an area you could cover with your thumb if you held your arm out toward the night sky. But here's what makes this truly terrifying. This map contains 10 times more galaxies than previous ground-based observations, and it contains twice as many as Hubble detected in the same region. Same area, same piece of sky, but with Webb's infrared vision, we're suddenly seeing 10 times more stuff, which means our estimates of the size and scale of the universe were off by a factor of 10. Think about that for a second. Imagine you thought your house had 10 rooms. You've lived there your whole life. You know every corner. But then one day, you find a door you never noticed before. You open it, and suddenly you realize your house doesn't have 10 rooms. It has 100 rooms. And you've been living in just 10% of it. That's what's happening right now with our universe. When we zoom out and look at the large-scale structure of the universe, we see something called the cosmic web, long filaments of galaxies connected by threads of dark matter with vast empty voids in between. We thought we understood this structure. We had models, simulations, everything checked out. But Webb is revealing that the cosmic web is far denser than we thought. There are more filaments, more connections, more structure. It's like looking at a detailed map and realizing it's actually a topographical map. There are entire layers we never knew existed. Earlier I told you that Webb can see back to just 200 million years after the Big Bang. But with these new discoveries, scientists are now detecting galaxies even earlier, including one galaxy catalogued as Omezi 14 that existed just 280 million years after the Big Bang. Every time Webb looks deeper, it finds more. More galaxies, more structure, more complexity. And that brings us to one of the most disturbing implications of all. If the universe is 10 times bigger than we thought, if it contains 10 times more galaxies, then the scale of cosmic emptiness is also 10 times larger. The voids between galaxy clusters, they're not just empty space. They're impossibly vast regions of absolute nothingness, stretching for hundreds of millions of light years. We are more isolated, more alone, more insignificant than we ever imagined. But isolation isn't the scariest part, because Webb also revealed something about the age of the universe that doesn't make sense. Okay, this next part is going to bend your brain, but stick with me, because it's crucial to understanding why scientists are so disturbed by Webb's findings. There's a problem in cosmology called the Hubble tension, and Webb just confirmed it's real. Here's the issue. When we measure how fast the universe is expanding, we get different answers depending on how we measure it. If we measure expansion using the cosmic microwave background, the ancient light left over from the Big Bang, we get one speed. If we measure expansion using distant galaxies and supernovae, objects we can observe directly, we get a different speed. The two measurements don't match. They're off by about 8 to 10%. Now you might think, okay, so there's a measurement error. Big deal. But in cosmology, an 8% discrepancy is catastrophic. It's like measuring the length of a football field with two different rulers, and one says it's 100 yards and the other says it's 108 yards. Both rulers can't be right. Something is fundamentally wrong. For years, scientists hoped this was just an error, a calibration issue, a statistical fluke. But in early 2024, Hubble and Webb worked together to confirm the measurements. And in January 2026, Webb pushed even further, observing galaxies at even greater distances. And the discrepancy got worse. The universe is getting bigger. But here's the problem, it's growing faster than it should. And right now, we don't know why. Scientists think the reason might be something called dark energy. Dark energy is like an invisible push. It's stretching space and making the universe expand faster and faster. The strange part? We don't know what dark energy is. We don't know where it comes from. But our measurements say it makes up about 68% of the universe. Now let's keep this simple. Most of the universe is made of things we can't see or understand. Dark matter makes up most of the matter. We can't see it. Dark energy makes up most of the universe. We don't understand it. Everything we do know, stars, planets, Earth, and us, that's only about 5% of everything. That means we can only directly study 5% of the universe. The other 95%? It's a complete mystery. And now, thanks to the James Webb Space Telescope, we're learning something even more shocking. Even that small 5% we thought we understood. Turns out we didn't understand it at all. But the Hubble tension gets even weirder. Because if the universe is expanding at different rates depending on where and how you look, then maybe expansion isn't uniform. Maybe different parts of the universe are expanding at different speeds. And if that's true, then the universe might not be the same age everywhere. Think about that. We say the universe is 13.8 billion years old. But what if that's only true for our local region? What if some parts of the universe are older or younger? What if time itself isn't constant? In September 2025, a team led by Professor Enrique Gazzaniga proposed something radical. What if the Big Bang wasn't the beginning? What if the universe has always existed in some form, and the Big Bang was just a transition point, a cosmic phase shift? This would explain the impossible galaxies. It would explain the Hubble tension. And it would mean that everything we thought we knew about the origin of the universe is incomplete. Now, most physicists aren't ready to abandon the Big Bang, but Webb is forcing the conversation because the data doesn't fit, and it's not getting better, it's getting worse. Which brings us to the most terrifying discovery of all, the one that made scientists question whether they've been looking at the universe completely backwards. In November 2025, Webb made a discovery that sounds like science fiction, but it's real, and it's shaking cosmology to its core. Webb detected what astronomers are calling gravitational mirages, light from distant galaxies that's been bent, twisted, and duplicated by massive concentrations of dark matter. This is called gravitational lensing. Einstein predicted it. We've seen it before. But Webb is revealing lensing effects so extreme, so complex, that scientists are starting to realize something profound. The distribution of dark matter in the universe isn't random. It's structured, it's organized. And the more Webb looks, the more it seems like visible matter. Stars, galaxies, everything we can see is just the surface. Dark matter isn't filling the gaps between galaxies. Galaxies are filling the gaps in the dark matter. Imagine you're looking at a sponge. You see the solid structure, the material the sponge is made of. But what if I told you that the holes are actually the important part? That the sponge material is just scaffolding around the voids? That's what Webb is suggesting about our universe. We've been studying the sponge, but the real universe is the holes. In January 2026, NASA released the highest resolution map of dark matter ever created. And the detail is astounding. You can see individual clumps, nodes in the cosmic web where dark matter is concentrated. These nodes are like cosmic anchors, and galaxies form at these anchor points. But here's what's bizarre. Some of these dark matter clumps don't have any visible galaxies at all. They're just there. Massive concentrations of invisible matter, shaping space and time with absolutely nothing we can see. Which raises a disturbing question. Are there entire civilizations out there made of dark matter that we simply can't perceive? Now, I know that sounds like wild speculation, and most scientists would say it's unlikely. But here's the thing. We don't know if dark matter can form complex structures. We don't know if it can organize into planets, stars, even life. We assume it can't, but we assumed a lot of things that Webb has now proven wrong. But let's leave dark matter civilizations aside for a moment, because there's something else Webb found that's even more concrete and even more unsettling. Webb has now detected the most distant galaxy ever observed, JD's GEDZ14 Zaups. This galaxy existed just 290 million years after the Big Bang. It's over 13.5 billion light years away. But here's the thing that keeps astronomers awake at night. When we look at this galaxy, we're seeing it as it appeared 13.5 billion years ago. But that galaxy still exists today, somewhere out there, in real time. Over those 13.5 billion years, the universe has been expanding. So that galaxy isn't 13.5 billion light years away anymore. It's over 30 billion light years away. And here's where the scale becomes truly incomprehensible. Light from that galaxy has been traveling toward us for 13.5 billion years. But if we tried to travel to that galaxy today, even if we could travel at the speed of light, we would never reach it, because the universe is expanding faster than light can travel. This is called the cosmic event horizon. There are parts of the universe that are moving away from us so fast that their light will never reach us, ever, no matter how long we wait, no matter how powerful our telescopes become. There are entire galaxies, entire clusters, entire superclusters of galaxies that are fundamentally, permanently beyond our reach. The universe isn't just big, it's separated into unreachable islands. And Webb has shown us that those islands are far more numerous and far more distant than we ever imagined. It's a strange feeling, isn't it? To realize that no matter how advanced we become, no matter how far we travel, there will always be parts of reality that are forever out of reach. We're not just alone in the universe, we're isolated in it. So let's take a step back. Let's zoom out, not just spatially, but philosophically. What does all of this mean? For thousands of years, humans believed we were at the center of everything. Earth was the center of the universe. The sun and stars revolved around us. Then Copernicus came along and said, actually, we orbit the sun. Then we discovered that the sun is just one star among hundreds of billions in the Milky Way galaxy. Then we discovered that the Milky Way is just one galaxy among hundreds of billions in the observable universe. And now, Webb is telling us that even that was an underestimate. There aren't hundreds of billions of galaxies, there are trillions, each containing hundreds of billions of stars. Each of those stars potentially hosting planets. Each of those planets a potential cradle for life. The scale is so vast that it breaks human comprehension. Our brains simply aren't wired to understand numbers that big. Let me try to put this in perspective. If you counted one star per second, it would take you over 31,000 years to count to 1 trillion. There are an estimated 2 trillion galaxies in the observable universe. That's 200 sextillion stars. That's a 2 followed by 23 zeros. And Webb is suggesting that even that might be too low. So where does that leave us? Some people find this scale terrifying. It makes us feel insignificant, meaningless, like cosmic dust in an incomprehensibly vast void. But I'd like to offer a different perspective. We are a species that has existed for less than 300,000 years. We've had written language for less than 6,000 years. We've had telescopes for less than 500 years. And yet, in that tiny sliver of time, we've managed to understand the fundamental laws that govern reality. We've traced the history of the universe back to its first moments. We've built machines that can detect the faint whispers of light from galaxies 13.5 billion years ago. We are made of atoms that were forged in the hearts of dying stars. We are the universe made conscious. We are the cosmos waking up and looking at itself. And that's not insignificant, that's extraordinary. But I won't lie to you. There's something terrifying about what Webb is revealing. It's not just that the universe is big, it's that we're realizing how little we understand. 95% of the universe is made of stuff we can't see or explain. Time might not work the way we think it does. The laws of physics might be different in the early universe. Galaxies exist that shouldn't be possible. We thought we were close to figuring everything out. The theory of everything seemed just around the corner. But Webb has thrown open a door to reveal an even bigger room full of questions we didn't even know to ask. And there's one more thing, one last discovery I need to tell you about, because it might be the most important one of all. When we look at distant galaxies through Webb, we say we're looking back in time. And that's true. We're seeing those galaxies as they appeared billions of years ago. But here's what we often forget. Those galaxies are still there. They're still evolving, still existing in real time. Right now, as you watch this video, there are trillions of galaxies out there, filled with stars and planets and possibly life going about their existence. We just can't see them as they are now. We can only see their ghosts, light that left them billions of years ago. Which means this: everything Webb shows us is simultaneously real and gone. Those beautiful galaxies in Webb's images, they might not look like that anymore. Some of them might not even exist anymore. We're seeing a universe that has already changed, already moved on, already evolved beyond what we can observe. And that's the final terrifying truth about the scale of the universe. It's not just that it's big, it's not just that it's old, it's that it's unknowable. No matter how powerful our telescopes, no matter how advanced our science, there will always be a horizon we can't see past, a boundary we can't cross. The universe is vast, ancient, beautiful, and utterly terrifyingly beyond our complete understanding. But you know what? That's okay. Because the journey of discovery, the pursuit of knowledge, the attempt to understand even a tiny fraction of this cosmic magnificence, that's what makes us human. The James Webb Space Telescope isn't just showing us the universe, it's showing us how much there is left to discover. And that's not terrifying, that's exciting. If you made it this far, thank you. Seriously, this was a journey. Webb will continue making discoveries. The universe will continue surprising us. And I'll be here to break it down for you. If you want to stay updated on the latest cosmic revelations, hit that subscribe button. Drop a comment and let me know. Do these discoveries make you feel terrified? Inspired? Both? Let's keep exploring it together. I'll see you in the next one.